Imagine this, a spacecraft the size of a small car hurtling through the infinite black at over 38,000 miles per hour, now more than 15 billion miles from Earth. That's farther than any human-made object has ever gone. Launched in 1977, Voyager 1 carries not just instruments and code, but a golden record etched with the sounds of Earth. Whale songs, Chuck Berry riffs, and greetings in 55 languages, a time capsule shouting our existence into the cosmos. For nearly 5 decades, it's been our silent ambassador, beaming back whispers from the edge of the solar system. But just this year in 2025, engineers pulled off a miracle that kept its voice alive a little longer. After months of garbled signals that had scientists holding their breath, they uploaded a software patch from 1.8 billion miles away. Wait, no, 15 billion. And Voyager started talking clearly again, revealing fresh glimpses of interstellar space. This isn't sci-fi. It's the raw grit of space exploration, where every byte counts and every signal feels like a victory against the void. Why does it matter? Because Voyager isn't just a probe. It's proof we can touch the stars, and its data is rewriting what we know about our place in the galaxy. Stick with me as we trace its epic journey from planetary slingshots to the brink of the unknown and ponder what secrets it might unlock before the lights finally fade. Voyager 1's story starts with a cosmic jackpot, a planetary alignment that happens only once every 175 years. Picture the outer giants, Jupiter, Saturn, Uranus, Neptune, queued up like perfect stepping stones, their gravity ready to fling a spacecraft outward on a grand tour. NASA, riding the Apollo high, greenlit the Voyager program in the mid-1970s, building two identical probes with tech that seems quaint today. Computers with less memory than your phone's calculator app, yet engineered to last. Launched on September 5, 1977, aboard a Titan 30E rocket from Cape Canaveral. Voyager 1 blasted off with a payload of 11 instruments, including cameras that would capture images sharper than anything before. Its first stop? Jupiter, arriving in 1979 after a 1.6 billion mile trek. What it found blew minds. Not just the Great Red Spot, a storm twice Earth's size raging for centuries, but 5 new moons, volcanic activity on Io-spewing lava like a solar system fireworks show, and rings around the gas giant we never saw coming. Short, sharp fact, Io's volcanoes are the most active in the solar system, thanks to tidal heating from Jupiter's pull, flexing the moon like cosmic dough. As Voyager swung by, using Jupiter's gravity as a slingshot, it gained speed, up to 42,000 miles per hour, and veered toward Saturn. That flyby in 1980 was pure poetry. Detailed shots of the rings revealing thousands of gaps and waves, like ripples in a celestial pond, caused by shepherd moons hurting icy particles. But Saturn's atmosphere hid dangers. Engineers had to tweak the scan platform mid-mission to avoid ring debris, a real-time fix that saved the day. By then, Voyager had traveled 1.3 billion more miles, its path set for the stars. These encounters weren't just postcards. They doubled our knowledge of the outer planets overnight, fueling dreams of what lay beyond. Transitioning from the bustling inner solar system to the quiet outer realms, Voyager's mission evolved. After Saturn, it didn't chase Uranus like its twin, Voyager 2. Instead, NASA pointed it north, out of the ecliptic plane where planets orbit, toward the constellation Ophiuchus. Why? To sample the sun's influence at different angles, mapping the heliosphere, that bubble of solar wind shielding us from galactic radiation, like checking a force field's edges. For years, it cruised in the Helios heath, the turbulent transition zone, sending back steady pings on plasma waves and cosmic rays. Remember, this probe runs on decaying plutonium pellets. Each year, power drops by about 4 watts, so teams at Jet Propulsion Laboratory in Pasadena have been playing power Tetris, shutting down cameras in 1990 to keep the essentials humming. Fast forward to 2012, August 25th to be exact. Voyager crossed the heliopause, the official boundary into interstellar space, 11.3 billion miles out. How do we know? Its instruments clocked a surge in cosmic rays, high-energy particles from supernovas zipping at near-light speed, and a dip in solar particles, like stepping from a warm room into a cosmic gale. Punchy truth, that crossing took 35 years, averaging 1 million miles a day, yet signals still reach Earth in about 22 hours, decoded by massive 230-foot antennas in NASA's Deep Space Network. Out there, the data gets weirdly beautiful. Magnetic fields flipping like a compass in a storm, plasma humming at low frequencies that sound like alien whale calls when sonified. It's not empty. It's alive with the galaxy's breath, challenging models that predicted a sharper divide. But space doesn't make it easy. Fast forward to late 2023 and into 2024. Voyager started glitching hard. Its flight data subsystem, the brain-handling science telemetry, began spitting invalid code, turning gigabytes of precious data into gibberish. Imagine your grandpa's old radio suddenly broadcasting static. That's 47 years of wear catching up, with radiation flipping bits in its ancient memory. Engineers couldn't diagnose from afar. No ping for error logs. So they got creative. In March 2024, they coaxed Voyager to shift its code to unused memory sectors, a 1970s workaround for a 21st century puzzle. By April, after 6 weeks of tweaks, clear signals flowed again, revealing nothing catastrophic. Just the hum of interstellar plasma, denser and cooler than expected. But 2025 brought fresh drama. In May, with primary thrusters faltering from sediment buildup, think clogged car fuel lines after decades, the team fired up backups dormant since 1991. These attitude control thrusters, key for keeping the antenna pointed at Earth, hadn't spun in over 30 years. Success. It bought time, but whispers of budget cuts loom. A proposed 26% slash for the Voyager program could force more shutdowns sooner. Here's a quick breakdown of those thruster stats. Primary set, 16 hydrazine-fueled jets, firing in pulses as short as 10 milliseconds. Backups, identical but untested in the cold void. The fix? A command sequence sent in February, executed flawlessly, proving human ingenuity outpaces entropy. Yet each save feels bittersweet. By 2030, plutonium decay will silence the last instrument. These aren't just repairs. They're tributes to the 10,000 folks who built Voyager, from welders to coders, turning a $865 million bet into humanity's farthest reach. Diving deeper into the data treasure trove, Voyager's interstellar revelations keep unfolding like a slow-blooming flower. Take the magnetic fields. Pre-2012 models said they'd snap at the heliopause. But nope, Voyager measured them, stretching seamlessly, solar lines reconnecting with galactic ones in a magnetic handshake that heats plasma to a wall of fire equivalent, though not literal flames. Temperatures spike to 54,000 degrees Fahrenheit from particle pileups, yet the probe sails unscathed in the near vacuum. No air means no conduction. Fun analogy, it's like revving engines in space. Energy builds but doesn't burn you. Cosmic rays? They're the stars of the show. Inside the heliosphere, the sun deflects them. Outside, they swarm, up 20% in intensity, mostly hydrogen and helium from ancient star explosions. In September 2025, fresh analysis highlighted a remarkable uptick in low-energy particles at the boundary, hinting at a dynamic edge where solar wind compresses interstellar gas, forming a cosmic surf zone. Compare that to Earth. Our magnetosphere blocks similar rays, but Voyager's unshielded. Its Geiger counter equivalent ticks like a Geiger in a thunderstorm. Plasma waves add poetry. They're oscillations from electron dances, recorded as electric fields humming at kilohertz frequencies. Sonify them, and you hear eerie whistles like the universe's soundtrack. These aren't abstract. They map how stars sculpt space, informing exoplanet hunts. Think TRAPPIST-1's worlds, where similar bubbles might cradle life. And the particles? Mostly protons zipping at 90% light speed, but rarer helium pickup ions from the sun surfing interstellar shocks. Data point, Voyager logs 1,000 cosmic ray events per second now, versus 20 inside. A 50-fold jump that recalibrates supernova models. It's basic to advanced here. Start with rays as space weather, end with them probing the galaxy's magnetic web, woven from a billion-year stellar forge. Now let's humanize this machine with the golden record, Voyager's Heart, a 12-inch gold-plated copper disc, a mixtape for aliens curated by Carl Sagan's team. Etched phonograph grooves hold 115 images. In 1977, amid Cold War chills, it was a bold, "We come in peace," prefixed by pulsar maps and hydrogen atom chirps as universal addresses. Fun fact, the record's needle arm deploys via a stylus, but playback needs 100-watt amps. Hopeful tech for ET. No responses yet, but theoretically, if advanced life decodes it, they learn we're carbon-based, math-savvy, prime numbers included, and diverse, from Navajo chants to UN speeches. Compare to Pioneer plaques, simpler line drawings of humans, Voyager's richer, like upgrading from a postcard to a novel. Sagan called it a bottle cast to the cosmic ocean, and at 15 billion miles, it's still adrift, potentially orbiting no star for eons. This isn't whimsy, it's astrobiology's seed, sparking SETI searches for reciprocal signals. Rhetorical nudge. What would you add to our next record? A meme, a climate plea, or Mars rover selfies? As Voyager pushes boundaries, its future gleams with milestones amid the fade-out. Come November 2025, it'll hit a light hour from Earth. Then, in 2026, a full light day, the farthest any craft has beamed human tech. That's 16.1 billion miles, signals lagging 23 hours one way. Position? Tucked in Ophiuchus, the serpent bearer, barreling at 3.6 astronomical units per year toward no particular star. Just the general stellar neighborhood, arriving at Alpha Centauri in 40,000 years. Challenges ahead. Power pinch by 2026 might kill the cosmic ray detector, last to go for its low draw. Budget woes could accelerate that. Insiders buzz about reallocating funds to Artemis or Europa Clipper. Yet legacy endures. Voyager's data, over 80,000 images, terabytes archived, fuels PhDs today, from heliophysics to astroparticle hunts. Hypothetical backed by science. If we send follow-ups like the proposed interstellar probe, launching the 2030s, it'd leapfrog Voyager using solar sails, reaching 1,000 astronomical units in decades, probing that plasma wall deeper. Earth versus Voyager, we spin at 1,000 miles per hour. It outpaces comets. Ongoing missions echo it. New Horizons at Pluto, Parker's solar probe dancing sun kisses. Implications? Safer deep space travel, radiation shields for Mars crews, even climate analogs in stellar winds eroding atmospheres. Wrapping this cosmic odyssey, Voyager 1 stands as humanity's boldest hello to the stars, a 1970s relic outlasting empires, teaching us the solar system's not a bubble, but a bridge. Key takeaways. Its slingshot tours redefined planets, revealing active moons and ring symphonies. Interstellar crossings unveiled a dynamic frontier of rays, fields, and waves that guard our world. Engineering heroics in 2024 to 2025 proved persistence pays, squeezing decades from dwindling watts. And that golden record? A timeless wager on connection, whispering we're here, we're curious, we're worth knowing. What if, amid the data deluge, we glimpse not just physics, but philosophy? That isolation's illusion, and the void invites reply. Ponder this. As Voyager dims by 2030, will we mourn or mobilize, launching bolder probes to chase its echo? For space enthusiasts, beginners decoding rays, or experts tweaking models, thanks for joining this voyage. If Voyager's grit fired you up, smash like, subscribe for more on interstellar probes and Mars updates. Hit that bell for alerts on NASA's next big reveal. Comment, what's your must-include on the next golden record? A puppy video or quantum equation? Check our playlist on solar system wonders and share with a friend staring at the night sky. Until the next signal, keep looking up. The universe is listening.